All right, now let's pick up where we left off. When you look at these formulas, the video we did the first time, okay, we used the formulas going from the left side to the right side, okay? Now I'm going to do a couple problems where we have expressions that look like the right side of these, okay? So it'll look like the right side, and we're trying to move over to the left side, okay? All right, so for instance, look at this problem. Suppose you're being asked to find the exact value of this expression. And so, it looks like a sum or difference formula for cosine or sine. So you go to your formulas and you need to pay attention to the cosines are together, the sines are together, and there's a plus sign. So that makes it cosine. So look at your formula sheet, go back up here and see. It's this one. We have the right side, okay, of the cosine of alpha minus beta. Okay, so we're going to rewrite this as the cosine of 50 degrees minus 20 degrees, which makes it the cosine of 30 degrees. And remember, in a 30, 60, 90 triangle, that cosine of 30 would be square root of 3 over 2. It's also okay if you have your unit circle to look at your unit circle. Right? Now this one is clearly one of the tangent ones. And on the tangent formulas, the minus on top kind of gives it away. So it's going to be the tangent of alpha minus beta of pi over 5 minus pi over 30. And so this is a fraction that you have to work with fractions here. So to be able to subtract fractions, you need a common denominator. So what we really have is 6 pi minus pi, which is 5 pi over 30. And that can be simplified by dividing by 5. And so let me just clean that up. We need the tangent. Oops, I want that in black. We want the tangent of pi over 6. And pi over 6, that's 180 divided by 6. That's really a 30-degree angle. And so we can look here, but tangent is opposite over adjacent. So I'm kind of thinking about that SOHCAHTOA. So SOHCAHTOA together with the special right triangles, or you can look at the unit circle if you needed to. So the tangent of pi over 6 would be 1 over the square root of 3. And if I rationalize that, it would be square root of 3 over 3. Right? So these were two problems, kind of like what we did before. It's just we're going in reverse. All right, now something quite a bit different that they ask you to do. I love these. I think these are really fun. Sometimes they give you information about your angles, and then your job is to find various things. So we don't know what the angle itself is, and we may never know what the angle itself is because we're not asked for the angle itself. So let's do these. So on A, I'm being asked to find the cosine of alpha. Okay. So what I'm going to do is take this information about alpha and see if I can't figure out what the cosine should be. So look, this is really important. You need to think about the quadrant. The quadrant is quadrant 2. That's where alpha falls. So let's say it's right here. Okay. If the sine of alpha is 12 over 13, you can draw a right triangle where you drop from the terminal side down to the x-axis and then form that right triangle and then label the sides of that right triangle. Okay, so 13 would be the hypotenuse. Let me put it in red. So 13 is the hypotenuse, 12 is the vertical height. Right? And you're looking at it, even though it's really, alpha is really here, remember how this would be the reference triangle? So you label it with this being the angle you're looking at. All right, so if we are going to use that to find the cosine of alpha, then I need to get the third side of this triangle. So I'm going to set up the Pythagorean theorem. I need to know that. So a squared plus 12 squared equals 13 squared. So a squared plus 144 equals 169, which makes a squared equal to 25. So a has to equal positive or negative 5. And which one it is depends upon the quadrant you're in. Okay, so if you're over here, a is really positive 5. So, technically a is 5. But I like to throw the sign on that because I like to kind of think about what the coordinates of this point would be. So I go, even though the length of the side is really 5, I like to go ahead and label it with a negative 5. But really, that's the coordinates of the point. Negative would be negative 5, 12. But it then allows me to just look at the triangle and think about the cosine would be negative 5 over 12. Negative 5 over 13 is what I should have said. Okay. Negative 5 adjacent over the hypotenuse. All right, so let's do a similar thing. We need the little pieces. We need all the pieces. Why aren't you moving down? So we need the cosine now of beta. So this is part B. So we're dealing with beta. So we're going to take the beta information. All right, and beta is in quadrant 1. So we're going to have beta in quadrant 1, okay, and it's the sign is 3/5. So we're going to drop that angle right there. This is beta, and it's 3/5. So make sure you label it correctly. Sine is opposite over hypotenuse. So the 5 is on the radius of the circle, if you're thinking about it like a unit circle. Okay, and then we're needing the cosine of that angle. So we need that missing side. Now this one, I don't think you should even have to use the Pythagorean theorem. You should recognize this is a 3, 4, 5 triangle. Okay, or you could use the Pythagorean theorem to get there, and then the cosine would be adjacent over hypotenuse. So it would be 4 over 5. Okay. All right, so now they're asking us, after we've done that, we're kind of done with the information, and we're ready to go in and do cosine alpha plus beta. And this is where you would go and you would look at your formula sheet. It's a cosine, so that means the cosines stay together and the sign changes. And then just verify that you've got that formula correct. And so we don't know what the angle is, but we do know each of these pieces. So we know this was negative 5 over 13. This was 4 over 5. Then the signs were given to us. So the sign of alpha was 12 over 13, and the sign of beta was 3 over 5. And so then you work on it. When you multiply fractions, that's the easy operation. You can multiply straight across and then simplify, or you can simplify first and then multiply straight across. Either way, you're going to wind up with a negative 4 over 13 in that first spot. So over here, that's a 13, a 3, a 5. You can't simplify on that one, so you're just going to multiply straight across. And you know what? I wish I hadn't simplified now that I looked at it. Since that one couldn't simplify, it's almost like, well, yeah, it was kind of pointless to simplify. Let me backtrack. And let's go ahead and just, since we need common denominators to be able to subtract, a negative 20 minus a 36 would be negative 56 over 65. And then I would have to see if I could simplify. So I would look at, probably the easiest thing to do there is just to type in the 56 divided by the 65 on your calculator and bring it back as a fraction. And you can tell that way real quick if it would work or not. So this would be the value for the cosine of alpha plus beta. So like you don't go and find what the angle is. All you do is look at information you have about those angles, right? And so then the other thing they want us to do is the sine of alpha plus beta for that one. And so we go and we look at the formula, and it says sine alpha cosine beta plus cosine alpha sine beta. All right, so it's the same stuff just being plugged in different places. So you have to be really careful. It's 12 over 13. And then cosine of beta was 4 over 5. That's multiplied. Cosine of alpha was negative 5 over 13. And then sine of beta was 3 over 5. Okay, and this is plus. If you can simplify first, feel free to do it, but you might take a lesson from what happened last time. Maybe it would be better just to take a look before we simplify. So this is really a negative 15 over 65, a positive 48. And 48 minus 15, what is that? That's 33 over 65. And so 11 doesn't go into 65, neither does 3. So that should be my final answer. Okay. All right, let's do one more of those, and let's do one and let's put a tangent into it, okay? Let's see if I can get a new page here. All right, and you might want to pause the video and try it, and then come back and see if you've got it right once I've written down what we're going to do. Okay, so what if, where did I write the one I wanted to do? Okay, so what if we knew that tangent of alpha equaled negative 3/4, and alpha was in quadrant 2. And then let's suppose that cosine of beta equaled 1/3, and beta was in quadrant 1. And okay. And then let's suppose I needed, what if I wanted to know, say, the sine of alpha minus beta? What if I needed the tangent of alpha plus beta? Let's try those two. Okay. All right, so you might want to think about what it is you're going to need. So it'd be okay if you wanted to go to the formula sheet and find out what pieces you need in order to answer those questions. So sine of alpha minus beta is sine alpha cosine beta minus cosine alpha sine beta. All right, and then I'm going to look at tangent. To do the tangent of alpha plus beta, I just need to know the tangent on both angles, don't I? Because that's going to equal the tangent of alpha plus the tangent of beta over 1 minus the product of those two. Okay, so I need the tangents for both, and I'm going to need sine and cosine for both. So I've got a lot of little in between things to find. So that's what you're really going to think about first. So let's take this piece here, and let's get the information we can from it. So alpha's in quadrant 2. So you're going to think about your angle being in quadrant 2. Not really trying to draw it to scale or anything. I just want to be able to draw that right there. So here's my alpha. And this is the angle I'm kind of focused on in the triangle when I'm trying to label the sides. So I want to put 3 and 4 on those sides, okay? And I know it's opposite over adjacent, so I know they're going to go like that. And then I have to think about how this point right here would have been -4, 3. So I like to just put the negative on that, even though I know the length of that side is 4, but I like to see the negative on it. That's going to be important, okay? All right, so then once you do that, I'm going to go over and just get the stuff I'm going to need about that. So cosine alpha, sine alpha, tangent alpha. Well, I already have tangent. And then in order to get the other two, I need the hypotenuse of that. And again, it's a 3/4, so you know that'll be a 5, or just use the Pythagorean theorem to get that. So the cosine is going to be adjacent over hypotenuse. And remember, look at this angle when you're thinking about it. Sine is going to be opposite over hypotenuse, and then we already had our tangent. Okay. All right, now let's look at the other piece of information. Let's see if I can squeeze that in right next to it. So this angle, I have to redraw my picture. It's in quadrant 1, okay? So get my triangle drawn. This is the angle they're talking about. That's beta, okay? Cosine of beta was 1/3. So if it's cosine, this would be 1, and then that would be over the hypotenuse. So I am going to need to use the Pythagorean theorem there. So I know that 1 squared plus b squared equals c squared. So b squared would equal the 9 minus the 1, or 8. And so b would equal the square root of 8, positive or negative. Okay, that would reduce or be able to be simplified into 2 square root of 2. And that, in the first quadrant, you should label it as a positive 2 square root of 2. Okay? All right, so then I have the cosine of alpha, beta, cosine of beta, the sine of beta, and the tangent of beta. And I know the cosine was 1/3. The sine is 2 square root of 2/3. And the tangent is opposite over adjacent. So the tangent turns out to be 2 square root of 2. All right. So if I'm trying to do sine of alpha minus beta, I know it's going to be right here. I'm probably going to need more room, so let me write it down here. I need the sine of alpha cosine of beta minus the cosine of alpha sine of beta. So that's for this part, okay? All right, so sine of alpha is 3/5. Cosine beta, that's 1/3. Cosine alpha is -4/5. Sine of beta is 2 square root of 2/3. Times in between these, but then minus in between that. Okay, so you could simplify first, but I learned earlier, didn't I, that it might be better to just wait and see what the denominators look like. Now, this is a negative times a positive, so that would be negative, and then there's a minus here. So I know it's going to be plus something. And I'm multiplying, so it's 8 square root of 2/15. And then I can put that together, but those are not like terms. And don't add the denominators. Remember, you get a common denominator, but then you just add the numerators. So that would be the exact answer for that one. Okay, and then the other one we were doing, okay, so that was the sine of alpha minus beta. Okay, the other one we were doing was the tangent of alpha plus beta. So we never found the angles. We're not being asked to find the angles. We're just being asked to find the exact value of this expression. Okay. All right, so what we're going to do now is plug in what we need. So tangent of alpha, tangent of beta. Tangent of alpha is a negative. Tangent of beta is 2 square root of 2. Okay. All right, so now I'm going to do a little bit of work just to clean it up a little bit. So let me show you what we have, and then we'll do some simplifying. So we have 1 really plus 6 square root of 2/4. Remember when you're multiplying things like 3 times 2 square root of 2, that the outsides get multiplied? And then this was minus a negative, so it became a plus. All right, so I can rationalize not rationalize, I can eliminate the little denominator by multiplying through by 4. So let's see where that gets us. That would be minus 3 plus 8 square root of 2 on top, and then 4 plus 6 square root of 2 on the bottom. All right, so we got a little more tedious algebra to do, but we can make it. So we'll finish that up. Let's see if I can get it. A little more paper here. All right, so here I'm going to start from this point, but I have a radical in the denominator. So I'm going to use the conjugate of that and multiply the top and the bottom by the conjugate. Because that'll get rid of the radical in the denominator. So we have a negative 12 plus 18 square root of 2 plus 32 square root of 2 minus 48 square root of 4. Remember when you multiply these, that the 8 times 6 go together and the square root of 2 becomes square root of 4, which will simplify down even more. 4 times 4 is 16. Outside would be minus 24 square root of 2. The inside would be plus 24 square root of 2. And then at the end, we have minus 36 times, square root of 4. When you get the hang of it, you can skip just a little bit of this stuff. All right, so this is negative 12. These are like terms. That's 18 and 32, so that would be 40, 50 square root of 2's. And then here, this is really 2. So I have minus 48 times 2, which is minus 96. Now here we did it because the radical is going to go away. See, this is really 2. So the denominator there becomes 16 minus 72. All right, so we're about there. And then 16 minus 72, that would be 56 negative. And then on top, I have the 12 and the 96 that I need to put together. So that's 50 square root of 2 minus 108. Okay. And it might be better to write that in front so you're not thinking it's under the radical. All right, and then I notice they're all divisible by 2, so I might knock them down by 2. Okay. And this is an excellent example to show something kind of tricky. See how the denominator has a negative in it? We usually rewrite that so it has a positive down there. And we do that by basically taking the opposite on top and bottom, multiplying the top and bottom by negative 1. And so this is equivalent to having negative 25 square root of 2 plus 54 over positive 28. And they'll usually write it like that or like this. That's why it'll be important that you turn in and show your work so that if you're making some careless mistakes, I can catch those if it's just basic arithmetic type mistakes. All right, I'm going to stop this and do in the next video finish up just by verifying a couple of identities.